So, at the present time, week of February 6th, we're going to start a new topic, matrices and linearity. At the end of the week, we have demonstration 1. And demonstration 1 covers the material of weeks 1, 2, and 3 from solving linear systems using Gauss's method up through Gauss-Jordan reduction and sort of chapters 1 and 2. And the form, it won't cover matrices and linearity. This topic is chapter 3. And it mainly is something like the homework, which is you'll download a LIX file and solve several linear system problems, then put that LIX file back on Piazza. And the LIX file, it doesn't will be constrained in the sense that you don't add new boxes. You'll just fill in the boxes that are already there. So it'll ask you, okay, perform 2 row operations to bring it to reduced row echelon form or something like that. There are 3 questions that sort of are about some general topics. But anyway, so that's the character of this one. So it'll maybe take a little bit longer than maybe just answering questions online is. What would take? Excuse me? Is it time? Yeah, all of these things, it works the same way as the concept check, in which I give you a fixed amount of time, and then you can choose when to start it, and you can use like the text and the other resources. The only thing that you can't do, or that's forbidden, is to communicate with other students, take it as a group, work on it together, check answers together, anything like that. That's forbidden. And so that's the main restriction. You just can't talk to other people in the course or outside of the course, or communicate with them in any way. So as long as that's good, then we will. Okay, that will be that. And okay. So the new topic is matrices and linearity, and it's sort of a bridge. This is the part 1 of this chapter is really completely separate from everything that's gone before, and we'll use it later on. So this stuff will appear. The purpose of putting it here is it's an independent topic and it's important, and so we're just going to isolate dealing with these tasks here. But we do make a connection in part 2 back to Gauss's law, and we'll see various connections between some of the concepts here and the linear systems. And then the 3 preliminary chapters in chapter 4, we'll get to the main topic of the course, which is vector spaces, which is the natural setting for understanding linear systems. So again, all our problems will still be solved with Gauss's method, but the concepts will be different, sort of like there'll be different avatars of the same problem. Okay, so and if you notice on let's see, go back to here, a new topic has shown up here. There are 4 new exercise sets here with that mimic the topics in the chapters. And they're all due on February 12th, which is this coming Sunday night. So these are sort of weekly participation exercises that you want to read the text, understand stuff, and answer these questions to verify that you're still engaged in the course. Okay. And also to remind you that you have, if you wanted to do, if you were working on the second version of assignment 1, that's also due this coming Sunday night. And the first version of assignment 2. So you're going to leave all these things like the demonstration and the assignment to the weekend, because you're going to end up getting overloaded. The other thing is that you need to look at this. There's a proof in here, and you need to sort of read through this PDF. And the best thing is to sort of come by and talk about the version of your proof beforehand, so I can critique it, so you don't end up there will be a second version of assignment 2, but the proof there will be different. So you may as well, it's better if you can sort of get a really good do well on these assignments so you don't have to do them again, because that saves a lot of time. Okay, so there's the mechanical stuff. And so we're going to start on our topic, matrix algebra, unless there's any questions. Okay, so matrix algebra. Well, we're going to start from the beginning. We've already did talk about matrices, but a matrix is an array of numbers, like a two-dimensional array of numbers, like this. And we're going to, because we're going to put matrices next to each other, we use parentheses to sort of block off the array here. So you need to put the matrices to indicate that this is a matrix. And the items in here, these are all the numbers in these different slots are called entries. Okay, so you notice that there's a two-dimensional because we have here 3 columns, 1 and 4, 2 and 5, and 3 and 6, and 3 rows. And you can remember a row is like a row of a field or a rowboat, that it's horizontal, and the column is like a Greek or Roman column that's standing vertical. So we have, and we label the rows and the columns with numbers. So, for example, this would be we call these indices. So these are the indices. Maybe it is. That doesn't look right. Let's just call it, each one of these is an index. Okay. So you have 1 and 2, first row, second row. First column, second column, third column. And we're going to give names. Excuse me?
Those numbers are the index.
I'm sorry.
Those numbers 1, 2, 3, and 1, 2, that's the index.
I'm missing the last.
Sorry, those numbers 1, 2, 3, and 1, 2, that's the index.
Somehow I'm missing the last. The numbers one. Which numbers? Maybe the problem is this. Oh, I see. Maybe let me change these entries because there's 2. The problem is there's 2, 1, 2, 3. So okay, let me do it. 4, 5, 6, 7, 8, 9. These numbers 1, 2, 3. They're the indices of the columns.
Okay.
First column, second column, third column. Sorry for I was confused between. And then these are the row indices. And these are the column indices. So we're going to name our matrices by capital letters. So, for example, we would write A equals 4, 5, 6, 7, 8, 9. So this equal sign just says this name is the name of this matrix that has the entries 4, 5, 6, 7, 8, 9. But we need names for the entries also. So we're going to use lowercase letters of the same type. If the matrix is capital A, we use lowercase a. If we had a matrix B, we'd use lowercase b. And then we're going to put subscripts for the letters I and J. We use I and J because those are standard letters for integers. And these are, of course, these are the index. The indices are obviously integers. These ones in here don't have to be integers. They can be any real numbers. So we're going to say these are the names of the entries, where the I for this matrix would be equal to 1 and 2, the first one. So we always have the row first, then the column. So you can sort of think, well, if I put indices over here, the row is on the left, and then you have the column sort of on the right. So then here J would go 1, 2, and 3. Now we can see this matrix has a certain size. We say it is a 2 by 3 of A, and sometimes the text will say it's the dimension of A. And those don't mean that there's nothing special about the word size or dimension. They're just specifying that there's a certain number of rows and columns. And so these numbers here are the sort of the limits. Like, for example, let's take another example so we can see this. Let's take the matrix B equals to 1.2 4/5 3 20.1 8 and 7. I would say this was a 3x2 matrix. E is a 3x2 matrix. So you read this as by, right? 3x2, because it's got 3 rows and 2 columns, and the entries, Bij, are the names of the entries where I goes from 1 to, well, it goes from, let's write this. We're going to say that this, in general, a matrix is M by N, right? In general. So the total number of rows here is 3. And the total number of columns here is 2. So we can say I goes up to M. And J, this is the row index, this is the column index J. That goes from up 1 to N, which here equals 2, here equals 3. So there's all of this is designed to just choose names for the entries in the matrices. So it's just a technology of names that's a little bit unwieldy, but once you become familiar with it, you can sort of precisely say what you mean by each of the numbers. So it's helpful, and these things here are useful for defining ways of combining. We'll need these to define how to combine matrices to make new matrices. Okay, so we're going to say, here's a notation. There's 2 kinds of notation. One is, we can say B is the matrix of the entries Bij. So this sort of, if you say let B equal the matrix of, you read this as B is the equals or is the matrix of the entries B subscript Ij. So it just connects up. You're just giving the names to this. So this is going to be helpful when we define sums and products of matrices, because we might have to introduce several names. Then you just introduce these standard names for the different matrices. And there's a second one, which is, let's say we have some unknown matrix P, and we want to know what its entries are. We'll say, well, this you read this as this is the entries of the matrix P equals. Oh, let me use another letter besides P, because the capital and lowercase are a little bit too similar. So we can say Cij equals Cij. Entries of matrix C are the Cij. So these are sort of 2 different ways of connecting up the matrix symbol with the entry. So it's just a little bit of notation for, if you're aware of it, it seems a little bit unwieldy, but it's will make things easier. Okay, let me